So this is the second part. It's example 4, 5, and 6 from 5.1. This first example tells you to factor. What did I tell you guys yesterday when it tells you to factor? How should we think? We just think like it's a normal factoring problem. Now, if I look at this, do I have two of the same trig functions or do I have different ones? So you could kind of look at this as this says like x squared minus y minus 3. Right? Could you factor that like it is right there? Can we factor that? No, because they don't have the same quote-unquote variables. They have different trig functions. So what we're going to do is change one of the trig functions so they all match the same. What do you guys think we should look at? Which theorem? That you guys have to think. That's why I'm not telling you what to do. Which theorem? Look at what you have. Look what identity. With what you have, what could you look at on your identity sheet and be like, maybe we can use this? Okay, Bella says the third one on the Pythagorean theorem. If I look at the third one on the Pythagorean theorem, I'm going to write it down. It says 1 plus the cotangent squared of x equals cosecant squared x. Does it make sense that Bella chose that one? Why does that make sense that Bella chose that one to use? Because it contains both trig functions that are in our original, right? They're telling us right now that when I have this cosecant, look, this cosecant and this one here, what can I replace cosecant with? What can I replace the cosecant squared with? The 1 plus cotangent squared. So all I'm going to do is rewrite this. Instead of cosecant squared x, I'm going to put 1 plus cotangent squared x minus cotangent of x minus 3. Questions at home? Do you guys see what I just did? How I took this and I plugged it in right there because they're equivalent. Everybody okay with that? Yes. Thank you for answering. You guys in here okay? Talk to me, friends. Talk to me. All right, now we're trying to factor. So before I go and say, okay, I'm going to factor this and all that, let's combine like terms here. Let's clean this up a little bit. If I rewrite this, because I don't have to distribute any negatives or anything, I could just say 1 plus the cotangent squared of x minus cotangent x minus 3. What can I combine? Yes, good. I can combine the 1 and the negative 3. So this becomes cotangent squared x minus cotangent of x, what? Minus 2. Now, look at what you have figured out here. It says to factor. Do I have the same trig functions throughout my whole expression? All right, so now I'm going to rewrite it, and I'm going to think algebraically. I'm going to think with just x's. I'm going to say this is the same as x squared minus x minus 2. Why I was going to put 12, I don't know. Can I factor x squared minus x minus 2? What are the factors of negative 2 that'll multiply to give me negative 2, but add to give me negative 1? Negative 2 and positive 1? Is that what you said, Andrew? Okay, good. And now that I've thought here, remember we're just thinking algebraically here. That's not my final answer. What do I do to give you my final answer? I replace the x with what? The cotangent. Good. So this first parenthesis would be cotangent x minus 2. And my second parenthesis would be the cotangent of x plus 1. And that would be your simplified answer. Now in section 5.3, when we get to it next week, we're going to actually solve each of those. It's going to be set equal to 0. And then you're going to find values on the unit circle. Not terribly difficult, just something different. But some of you, again, you guys are going to say to me, well, can I check this? Absolutely. Watch. If I write cotangent x minus 2 times cotangent x plus 1, all right, multiply. I get cotangent squared of x plus cotangent x minus what? 2 cotangent of x. And then minus 2. When I combine here in the middle, I have cotangent squared x minus cotangent of x minus 2. Is that what we started with right here? Yep. So we're good to go. Questions? Remember, factoring is generally a little easier. If it all has the same trig function, you just think of it algebraically, factor it like you normally would with x's, and then plug the trig function back in. If they don't all have the same trig function, then you just have to do a teeny little bit of manipulation to get it to be the same. All right, let's look at this one. Remember, it says to simplify. What did I tell you when it says to simplify? It's going to be super easy, or there's lots to do? Lots to do. Remind yourself. Lots to do. Simplify means to make small. So this is where you guys are going to be like, well, how do you know if you're done? How do you know to stop? It's when you keep looking back at your identities and there's just nothing else you can do to simplify. So the first thing I'm going to do is I'm going to rewrite. I'm not going to use t because my t's start to look like pluses and we get all confused. But your simplest trig functions are sine and cosine. So if you notice here, you have a sine and you have a cosine. So we might be able to, like, whenever you're trying to simplify and you don't know which direction to go, think you want to try and get everything in terms of sine and cosine. You want to get everything as small as possible. So I can't really do anything with the sine. I'm just going to keep it as the sine of x. I mean, I could turn it into a reciprocal function, but fractions doesn't mean necessarily that we are getting anything to be any smaller or anything like that. So plus, look at your identity sheet. In terms of sine and cosine, what is cotangent? What can I replace that with? Cosine over sine? Okay, Lexa tells us cosine of x over sine of x. Okay, I agree. Remember, we said our most basic functions would be sine and cosine, so that helps. And then I still have my times cosine of x. Everybody agree? Yes or no? All right, this is like a puzzle. We're going to try and get everything to, just kind of simplify a little bit. So I have the sine of x plus, well, if I multiply these two together, what does my denominator become? Cosine times cosine is cosine squared x over sine of x, all right? What is the first sine of x over? It's over 1. Okay, so think about this. Whenever you guys get to something like this and you're like, okay, wait, this is the same thing as saying 5, I'm just picking a random number, plus 7 over 3. If I told you guys you were going to add those, what would you have to get? A common denominator, right? So the common denominator between 1 and 3 would be 3. So I look back here at my trig function. I need a common denominator between 1 and sine of x. What would it be? Sine x. So if I want to get this to have the same denominator, so I want everything to be the same. So I'd have to multiply the bottom here by sine of x. What you do to the bottom, you do what? To the top. Good. So if I have sine times sine, that gives me what? Sine squared. Plus, this already has a sine of x, so I don't need to do anything else. All right, now I'm sitting here and I'm like, well, now what? I have sines and cosines, but this doesn't look simplified to me. Does this look nice and easy and simplified? Not yet. Look at your identities. Think. Look at your identities. I have sine squared x plus cosine squared of x. Okay. If I look at my Pythagorean identity, the first one says sine squared x plus cosine squared x equals what? So I can replace this whole numerator with what number? There you go. So this becomes 1 over sine of x. I mean, that looks pretty simplified from what we started with, but is there anything, look at your identities, is there anything I can do to make that look even simpler? Does 1 over sine of x equal anything? Hang on. So again, let's go over that again since it was in the middle. Is there something on your identity sheet that you could simplify even more so you don't even have a fraction that 1 over sine of x equals? it equals the cosecant, whoops, of x. And that would be your simplified answer. The first step of figuring out where to go, where to start, what to do, that generally is the hardest part. And the best advice I can give you is to try something. Don't create your own math, but try something. Some of you are going to say, well, are there different ways to do this? Not so much different ways, but you might take the longer route. Some of you might use different identities in different places that may make your process a little longer, and that's okay. But as long as we get to the simplified answer, that's what we're looking for. Again, I know this is kind of like, oh my gosh, that's why we're going to practice it. I got one more to do, and then we're going to practice with your homework. On 5.2, we do the verifying, you'll see tomorrow. You don't have a web assign for the actual verifying part because the way that you have to enter it into the computer will drive you guys crazy. So you're going to have a PDF to practice it. So it's not that difficult to do, okay? My next cosine. We okay? All right, let's look at the last one. It says to rewrite 1 over 1 plus sine of x so it's not in fractional form. That means your answer should not be a what? Should be a fraction. Okay, this one's got some steps to it, guys, so let's just think for a second. Let's think. I'm going to rewrite the original problem. Excuse me. I have 1 over 1 plus the sine of x. Okay, the first thing I think is I don't want a fraction, right? I have a binomial in my denominator. If I had 1 over 2 plus 3i, you agree with me that's a binomial in the bottom? What would I do to get rid of the 2 plus 3i? Multiply by what? I agree. Do I multiply by 2 plus 3i or 2? Remember, we do the conjugate. 2 minus 3i. Top and bottom by 2 minus 3i. Same concept goes here. If you ever have a fraction in your denominator and you're trying to get rid of it, the first step would be to multiply by the conjugate. So what's the conjugate of 1 plus sine of x? Okay, 1 minus sine of x on the bottom. What you do to the bottom, you do where? Is everybody okay with that? The direction said, I don't want a fraction. So the first thing you need to do is try and get rid of, oh, my nose is so itchy, I'm sorry. You're trying to get rid of the denominator. So if I just multiply the top, I have 1 minus the sine of x. Everybody agree? Okay, now let's do the bottom. 1 times 1 is 1. 1 times negative sine x is minus sine x, right? Sine x times 1 is plus sine of x. And sine x times negative sine x is negative what? Sine squared of x. My sine x's cancel out, correct? So I'm left with 1 minus sine squared x. Did that get rid of my denominator completely? Mm-mm. But it helps. Remind yourself, guys, every single time, if you start off with a denominator, just multiply by the conjugate. That's the first step to kind of get your process going. Because now we're looking at this and we're like, okay, well, we're trying to simplify. We're trying to get rid of that denominator. Can I just cross off the 1's and one of the sine x's and just say, oh, I have 1 over sine of x? No. Remember, guys, this is in parentheses. They're together. Since they're not exactly the same, I can't do that. But I can look at my identities and say, something will help me here. Something will help me simplify that denominator. Look at your Pythagorean identities. What do you think would help you simplify that denominator? What has a 1 and a sine squared of x in it? The first one. 90% of the time, you guys are going to that first one. Sine squared x plus cosine squared of x equals what? 1. What would I do to my yellow formula to make it look like the red one? What would I do to the yellow to make it look like the red parenthesis of 1 minus sine squared of x? Okay, subtract which one? Okay, if you subtract cosine, you could do that, and then you'd have another step. What would be a faster way to get there? Can I manipulate that yellow formula so on one side of the equal sign it says 1 minus sine squared of x? Right? If I subtract the sine squared here, and I subtract it here, I'm left with cosine squared x equals 1 minus sine squared x. Agreed? So instead of this right here, what can I replace it with? I can replace it with cosine squared. You guys see that? So I'm left now with 1 minus sine x over cosine squared of x. Now we still have a denominator, but this is much easier to work with now. Much easier to work with because it's just one single term. It's not two terms separated by a minus or plus sign. So now you're thinking, oh man, now what? Think about this. This is a fraction. Again, I know this is hard. This is different. This is new. Think about this as a fraction. I have two terms on top and one on the bottom. Is there another way I could rewrite this fraction into two smaller fractions? Ooh, Andrew, I like it. 1 over cosine squared of x minus sine x over cosine squared x. All right, good thinking. You can separate fractions like that. Everybody agree? Okay, so let's look at our identities. Let's look at each piece separately. Let's look at our identities. Is there something on our identity sheet that looks like this? Maybe not squared. You can interchange the squareds. But can I replace 1 over cosine x with something else? Okay, 1 over cosine is secant. So 1 over cosine squared x, what do you think that equals? Secant squared. Good. Yep, good. Very good, my dear. Good, good, good. All right, now, I can't just cross anything out here. I know this is a lot. I know. And I promise, the more we do it, the easier it'll get-ish. Can I rewrite this as... Hold on. Are those two things the same thing? Yeah? So I could split it up, just like we split up the last one, and I could split this up as sine x over cosine x times 1 over cosine x. Right? Because I have the square root of the denominator. Remember, there's two. You can just pull it apart. That's okay. Look at your identity sheet. Can you do anything? I'm going to bring this down a little bit. Can you do anything with sine x, cosine x? Does that equal anything? Sine x, cosine x. Does that equal anything? You're right, David. I'm just seeing if anybody else is going to participate. Look on your identities, guys. Sine x over cosine x. What is that the same as? Tangent of x. Okay. 1 over cosine x. What's that the same as? Yep. Now, I can stop right there. Why can I stop right there? What were the directions? What were the directions? Can't be a fraction. It says, rewrite it so it's not a fraction. Does anybody see, with what's left over, could you simplify this a tad bit more? Yeah. How, Bella? I know you see it. How? Okay, what do they both have in common? They both have a secant. So you could take one of them out, secant x, and then you'd have secant x minus tangent of x. That would be the same thing. That would be an answer that I would take because it's simplified and it's not a fraction. You could use either of those. But you don't have to because the directions just stated, write it so it's not in fractional form. So the second you get to where it's not a fraction, you're like, oh, okay, this is cool, I got this. Right here. Now, I know, you guys are sitting here going, how in the world? You need to watch me do this problem a couple times in the video. But every time you have a fraction, always think about multiplying by a conjugate to try and get the binomial out, like if it's 1 plus something, 1 minus something. And then when you have a fraction, think you can always pull it apart, pull it apart, pull it apart. Do you see that's what we did in a lot of these? We pulled it apart, pulled it apart, pulled it apart. You can keep pulling it apart using your math skills. It's just different. It looks weird. It looks really difficult because there's a lot of words in this.